Hello, this is a test video to see if I can even do this, so consider it an experiment. Well, let's get started then. I have no idea what I'm doing, but that's okay. That'll make it fun, for me at least. So I wanted to talk about the laws of logic, because I think that they are interesting, and I kind of know what they are, so I think it'll be sort of easy for me to talk about them. The first law of logic is the law of identity, which, simply stated, is that whatever is, is. So for every proposition A equals A, or for every entity A equals A. It seems pretty straightforward. Some examples of the law of identity in practice are things like tautologies, like a hammer is itself, or an apple is an apple, or magic is magic. To borrow from a common cultural phrase, love is love. That is obviously that's tautologically true, and that's the law of identity in practice. The second law is the law of excluded middle, which simply stated is everything must either be or not be. So every proposition is either true or false, basically. Either A is true or A's negation is true. So either the positive form of A or the negative form of A is true. But there's no middle option there. It's binary. Some examples are any truth claim and all mathematical statements. They're either true or false. There's no secret third option that you could choose. There's only two. For any truth claim or for any mathematical statement, it is either true or false, period. The third law of logic is the law of non-contradiction, which can be simplified by saying nothing can both be and not be. A proposition cannot be both true and false in the same sense simultaneously. So, another way of saying that is, it is not the case that A is true and A's negation is true. An example of that are things that are mutually exclusive. So, for example, it is not the case that God exists and atheism is true. Those two things are mutually exclusive because atheism is the claim that God does not exist. So you can't have God exist and not exist simultaneously. That is a contradiction. So according to the law of non-contradiction, you cannot claim that atheism is true, and God exists. Those two things cannot be true, both true, in the same sense. And Gottfried Leibniz, who is probably the greatest being that Germany has ever produced, also proposed two other laws of logic, but they're not always grouped in with the fundamental laws of logic, so I'm just calling them Leibniz's laws. The first one is the principle of sufficient reason, which basically states that no entity X exists without a sufficient explanation for why X exists. So I exist, so according to the principle of sufficient reason, there must be some sufficient explanation for why I exist. This also applies for propositions. No proposition is true without a sufficient explanation for why it is true. So the proposition 2 plus 2 equals 4 is true, and there is a sufficient explanation for why 2 plus 2 equals 4. It's the rules of arithmetic, the rules of addition. Like when you add 2 and 2 together, you get 4. That's 4 is by definition is the sum of 2 and 2. So there's a sufficient reason for the proposition 2 plus 2 equals 4 to be true. And also, no event E occurs without a sufficient explanation for why E occurs. So, for example, the President of the United States was elected. Therefore, there is a sufficient explanation for why the President was elected. And the second law of Leibniz's is the indiscernibility of identicals, which I like to summarize by saying if you have two things and those two things are identical, then what is true of one will be true of the other. So if x and y are identical, then x and y share all the same properties. And if x and y share all the same properties, then x is identical to y. This is very similar to the law of identity, but it's kind of worded in a different way, and it can apply to things and not just propositions. So I thought I would throw it in here. So now that I've kind of touched on the laws of logic, I kind of want to go into some rules of inference. There's a lot more than these 5, but these 5 are fairly common, and they're also my favorites, so I wanted to talk about them. The first one is modus ponens. So, which basically says that if P is true, then Q is true, and P is true, therefore Q is true. This is a way of formalizing something that you could say in propositional logic. So, like, if I'm a man, then I am mortal, and I am a man, therefore I am mortal. It's a simple propositional syllogism. It's got a conditional premise and then a more simplified, just concrete declarative premise, and then the conclusion, which follows according to the rule of modus ponens. The second one is modus tollens, which is basically if P is true, then Q is true. However, Q is false, therefore P is false. And a practical application there would be something like, if I am a cow, then I have 4 legs. I do not have 4 legs, therefore I am not a cow. So why this is useful, and it's kind of like a companion to modus ponens, is that you can see that you can establish something as true in the first premise, and then the consequent, which is the basically the second proposition in the first premise, you can see that if it's false, then the first proposition is also false. But it only works if you deny the consequent proposition. If you affirm the consequent, then you've committed a logical fallacy known as affirming the consequent. That's a video for another time. Anyways, this next rule is contraposition. Any conditional statement is logically equivalent to its contrapositive. So P implies Q has the contrapositive not Q, therefore not P. So if P is Q, then Q is true, is equivalent to if Q is false, then P is false. The proposition, all trees are plants, can be rephrased as a conditional statement. If something is a tree, then it is a plant. And contraposition says that that statement is logically equivalent to its contrapositive. If something is not a plant, then it is not a tree. This should seem fairly intuitive. You probably have used this line of reasoning plenty of times without even being aware that there was a name for it. But I find it useful to kind of know what it is and have a good concrete conceptualization of it, so I thought I would throw it in here. The next one is conjunction, which basically means, so you have two conjuncts, P and Q. P is true, Q is also true. Therefore, you could put them together and say P and Q is true. So if proposition P is true and if proposition Q is true, then it follows that the conjunction of those propositions, P and Q, is also true. So first proposition, I am driving. The second proposition, I'm in my car. Therefore, the conjunction of these propositions is I am driving and in my car. That is one statement, and it is just as true as the two separate conjuncts. And similarly, we also have a disjunction, which P is true or Q is true. P is false, therefore Q is true. So the example I have here is it is Sunday, or the post office is open. It is not Sunday, therefore the post office is open. So yeah, this has been my high HD definition quality video. I'm might never do this ever again because I have no idea what I'm doing and I don't possess any editing software. So all of this is done pretty much in one take. But if somehow people find this video and if for some reason they want to see more, then I will probably make some more. Or maybe I'll just make some more for fun. I don't know. It's really early in the morning, so I think I'm gonna go to bed.